Hello everyone. In this video we will discuss about AC-DC rectifier, single phase, half wave, control rectifier, and our load is resistor and inductor. So we have resistor and we have inductor. For control rectifier we use SCR or sometimes called Thyristor. We know that the Thyristor we can turn on after we supply, we inject the gate current. We inject current to the gate terminal, so this transistor will be turned on. Without gate current, the transistor cannot be turned on. Okay, so now to analyze this circuit, we divide it into a few sections. So from 0 to alpha, one section. Second section is from alpha to pi. Third section is from pi to beta. And fourth section is from beta to pi. Okay, we divide it into 4 sections in order to analyze it. So we start with the first section, which is from 0 to alpha, which is positive cycle. Okay, for positive cycle like this. Okay, voltage will be like this, and current will flow this from positive terminal, go to SCR, go to Thyristor. Okay, in this case, from 0 to alpha, okay, look at gate current. From 0 to alpha, there is no gate. Okay, Ig equal to 0. Okay, to switch on the thyristor, we need Vs greater than 0 and I gate not equal to 0. So we have to provide gate current. Then the thyristor will be on. Okay, in this case, gate current is 0, Vs greater than 0, and Ig equal to 0. So what happened is the thyristor will be off. Or sometimes we call forward blocking mode. Okay, forward blocking mode. So thyristor will be off. When the thyristor off, so current cannot flow. This I equal to 0. So I out also equal to 0. Current cannot flow. So when I out equal to 0, V out will be equal to 0. So output, then the output will be equal to 0. Okay. So at 0 to alpha, our output is 0. I naught also 0 due to off. Open circuit here. Open circuit I naught equal to 0. Then how about the thyristor voltage? Okay, we're using KVL here. KVL V thyristor equal to Vs minus V out. V out equal to 0. So V thyristor equal to Vs equal to Vm sine omega t. Okay, our waveform is Vm sine omega t. This is our Vs. The output from 0, the thyristor voltage from 0 to alpha will follow the input. Okay, follow the V source. Same. Okay. Okay, same shape. This is the input from 0 to alpha. Okay, due to forward blocking mode of the thyristor. Our thyristor is off condition. So we get this waveform. Okay, that one is during first section. So now we go to second section. Second section is between alpha to second section between alpha to pi. Okay, from alpha to pi. Okay, let me erase first. Erase. Okay, second section is from alpha to pi. Okay, from alpha to pi. Okay, this one is positive cycle. So we still provide positive cycle from alpha to pi. Okay, current will flow from positive terminal go to our thyristor. Okay, at alpha we supply gate current. Okay, so gate current supply here. We inject gate current to gate terminal. So gate current is not equal to 0. Okay, in this case Vs greater than 0 and I gate not equal to 0. That's mean we inject current at alpha. So what happen is diode will be the SCR will be on forward conducting mode. Okay, so we will switch on short circuit here on short circuit. Okay, 0 volt. So when our thyristor short circuit, so current can flow. Okay, current will flow from positive terminal go to load. Our load is a resistor and also inductor and go back to source. So we have current can flow here. So we know that this voltage is equal to V equal to IR. This voltage will be equal to L di over dt. So now we have output. So okay, output is combination of both. V out. We know that for short circuit here, 0 volt here. So using KVL here, KVL, V out equal to V source minus V thyristor. V thyristor is a 0 due to short circuit. So V out will be equal to Vs equal to Vm sine omega t. Okay. So during second section, V out equal to Vs sine omega t. So from alpha to pi. So the output will be same as the input. So this is our input. So our input exactly, our output is exactly same as the input. Okay, input waveform from alpha to pi. Okay, in terms of current, we know that this is our inductor. Inductor will charging when it receive current. So current flow, this current flow through inductor. Inductor will charging and store energy. Charging and store energy. Okay, it will charging and store energy start from alpha until beta until pi. So we are charging charging. Okay, from alpha to pi, it will charge. Our inductor will charge mode. Okay. How about the thyristor voltage? We know that during on condition means that thyristor equal to 0. From alpha to pi, thyristor will be, the thyristor voltage will be 0 volt on, on state, or sometimes you call it short circuit forward conducting mode. Okay, that one is during second region. Okay, now is at the third section. Okay, let me erase first. Okay, third section is from pi to beta. Third section. So from pi to beta. Okay, this section is the negative cycle. Our input will be negative. So negative polarity like this. So plus here, minus here. Okay, during positive cycle, the inductor is charging. During positive cycle, store energy. Then during negative cycle, then when we change to negative cycle means that there is no current flow. There's no current flow to charge the inductor. What happens is the inductor will become current source during negative cycle. The inductor will become current source. So it will supply current. It will discharge current. Discharge energy. Okay, discharge energy in terms of current. So current will flow from inductor, from this current source go to the cycle, to the complete cycle. So we can see that this and this will be same direction, and then the SCR still on at this time, still on, and when this SCR on, the voltage will be 0, short circuit. What is that? Short circuit. So current will flow. We have current. Okay. How about V out? V out equal to Vs minus Vt. Vt is V thyristor. Thyristor equal to 0. So V out equal to Vs equal to Vm sine omega t. So it means that V out is exactly same as V input. So V input is like this. So V out will be follow exactly same as the V input from pi to beta. Okay, this one. Okay, this is V out. V in like this. V out follow V in. Okay, look at this. The current source, the current source, the current. Okay, the discharging current will be finished. Okay, we know that during positive cycle, the inductor will charging. During positive cycle, charging. Then at pi, the output, the input is changed to negative cycle. Then the inductor will become current source and will discharge. It will discharge the energy in terms of current until empty. At beta, the energy will be empty. Then this inductor there is after beta there is no current. There is no current supply by the inductor, and this inductor will become as inductor. Before this, it become current source. Now the current source change to inductor due to there is no energy anymore. Okay, inside the inductor. Okay, that one is during pi to beta. Okay, for V thyristor, we can see that our thyristor is on. So that means short circuit and voltage is 0 volt between from pi to beta. Okay, from pi to beta, short circuit 0 volt. Okay, that one is at the third section. So now at the fourth section, between between beta to pi. Fourth section, beta to pi. Okay, what happened is, okay, now we know that at this point the current source is empty. Okay, current will flow from positive terminal, go to inductor, go here, and go here. Okay, you can see that this is opposite. Okay, means that the SCR will be off. Reverse blocking mode. Okay, Vs less than 0, Ig no Ig, so SCR off. So when SCR off, current will be 0. So current 0. Okay, 0 ampere. So when current, and also V out will be 0. Current cannot flow, so there is no voltage drop at R and also at inductor. That means our voltage will be 0. V equal to IR, I equal to 0, so V equal to 0. This one. Okay, 0 volt between beta to pi. And how about the VT? VT is equal to Vs minus V out. V out to 0. So Vt will be equal to Vs equal to Vm sine omega t. Okay. So our Vt will be follow the input. Okay, graph the input like this. Okay, let me change the color. Okay, input cycle like this from beta to pi, input like this. So exactly follow the input from beta to pi. Okay, our thyristor voltage same as source voltage. This one is 0. Okay, that one is during fourth cycle. So now we are finished. So the next cycle is just repeat the previous one. Repeat. So it will repeat again waveform. Okay, that's all for waveform. For the response of the waveform of each component we have input, waveform of input, waveform of gate current, waveform of output, waveform of input, output current, and also waveform of thyristor voltage. So now we go to the derivation of the equation. Okay, let's erase first. Okay, let's derive the equation. Okay, first equation is as usual, V average equal to area under the curve over period. Okay, V out, we take a V out. Average is area under curve is equal to this area and this area. Our graph is Vm sine omega t. So we 1 over t is equal to 2 pi from alpha to beta. Vm sine omega t d omega t. So what we get is equal to Vm over 2 pi alpha beta sine omega t d omega t equal to Vm over 2 pi cos alpha minus cos beta. Okay, this is our V average. How about I average? I average equal to V average over R. Okay, V average over R. This is our R. Just Vm over 2 pi R cos alpha minus cos beta. Okay, that one is V average. That one is I average. Okay, next is VRMS, root mean square. Root mean is V average square equal to, okay, we just square it, 1 over 2 pi. So V average is equal to from alpha to beta Vm sine omega t, okay, square d omega t will be equal to 1 over 2 pi, take out Vm square alpha beta sine. Okay, next if we solve it, we will get one over pi beta minus alpha plus sine 2 alpha over 2 minus sine 2 beta over 2 1 over 2. Okay, this is the equation for VRMS. Alright, I think that's all for AC DC rectifier. We're using resistor and inductor load control rectifier using Thyristor and resistor inductor load. Okay, that's all. Thank you. Bye bye.